In 6.1, we're going to look at composite functions, or function composition. So here is an example where we are looking at composites taken using a table. And we have a table that includes x values, f of x values, and g of x values. So first we're going to find f of g of 1, and that's how you say this. First, we're going to find g of 1. So in the table, we find where x is 1, we find the g value of the function, and that is 0. And we're going to take that 0 and feed it into the f function. So now we need to find f of 0. So find 0 in the table and find the f value, which is 5. So f of g of 1 is 5. Next, let's find f of g of 2. So we've got f of g, and we are going to start with the rightmost function. So g of 2, find 2 in our table, find the g value, and that is -3. So g of 2 is -3, and that -3 will get fed into the f function. So f of -3, find -3 in our table, and f of -3 is 11. So f of g of 2 is 11. Let's look at g of f of 2. So now the rightmost function is f, and we're going to find f of 2 first. So find 2 in our table and find f of 2, which is 1. And now that 1 will get fed into the g function. So g of 1, find 1 in our table, find g of 1, which is 0. So g of f of 2 is 0. Let's find g of f of 3. So again, our rightmost function is f, so find f of 3. Find 3 in the table. Find f of 3, and that is -1. So f of 3 is -1. And that -1 will get fed into the g function. So g of -1, we find -1 in our table, and find g of -1, which is 0. So g of f of 3 equals 0. Now we'll look at g of 1. So our rightmost function is g. We'll find g of 1. So finding 1 in our table, we'll find g of 1 is 0. And now that 0 will get fed into the g function again. So g of 0, find 0 in the table, find g of 0, which is 1, and g of g of 1 is 1. Okay, finally, let's find f of 3. So our rightmost function is f. Let's find f of 3 first. So we'll find 3 in our table, find f of 3, which is -1. That -1 will now be fed back into the f function. So we're finding f of -1. Find -1 in our table, and f of -1 is 7. So f of 3 is 7. Okay, we can also find function composition by looking at graphs of two functions. So here we have two graphs. The graph of g of x, which is the one that is higher up or more on top, and we have the graph of f of x, which looks almost like a check mark. And these do not go on forever. They're actually bounded by points. So first, let's find g of f of 1. So our rightmost function is f, so we're going to find f of 1 first. So on our f function, find the point where x is 1. And we're looking at our y value, which is -1. So f of 1 is -1. And now that -1 will get fed into the g function. So we need to find g of -1. So on the g function, find the point where x is -1, which is here, and our y value is 3. So g of -1 is 3. So that makes g of f of 1, 3. Okay, now let's look at g of f of 5. So again, our rightmost function is f. So we're going to find f of 5. On the f function, so the check mark shaped function, let's find the point where the x value is 5. and the y value is 1, so f of 5 is 1. Now that 1 will get fed into the g function, so we're looking for g of 1. So on the g function, find the point where x is 1, and look for the y value, which is 4. So g of f of 5 is 4. Let's find f of g of 0. Our rightmost function is g, so let's find g of 0. On the g function, let's find the point where x is 0. That's where it's going to cross the y-axis, which looks like it is at y equals 5. That 5 will get fed into the f function, so we will find f of 5. On the f function, find the point where x is 5, and at that point, y is equal to 1. So f of g of 0 is 1. Finally, let's find f of g of 2. Our rightmost function is g, so let's find g of 2. On the g function, let's find the point where x is equal to 2. The y value there is 2. That 2 will get fed into our f function, so we're looking for f of 2. On the graph of f, let's find the point where x equals 2, and the y value there is negative 2. So f of g of 2 is negative 2. We can also do function composition given function definitions. So here we have f of x equals the absolute value of x minus 2, g of x equals 3 over x squared plus 2, and we're going to find these 4 function compositions. So I'm going to use, here it's best to do a lot of color coding, so I'm going to do my f of x function in red, my g of x function in blue, and let's first find f of g of 4. So my rightmost function is g. We're going to find g of 4 first. So substituting 4 in for x in the g function, we get 3 over 4 squared plus 2, or 3 over 18, which simplifies to 1/6. Now that 1/6 will be fed into the f function, so we will look for f of 1/6. So now using the f function, we're going to substitute 1/6 in for x. So we will find the absolute value of 1/6 minus 2, or the absolute value of negative 11/6, which is 11/6. So f of g of 4 is 11/6. Next, let's find g of f of 2. So first, our rightmost function is f, so we will find f of 2. So taking the f function and substituting in 2 for x, we get the absolute value of 2 minus 2, or 0. And we will feed 0 into the g function. So g of 0, substitute 0 in for x in the g function, so 3 over 0 squared plus 2, or 3/2. So g of f of 2 is 3/2. Let's look at f of 1. So our rightmost function is f. So we'll find f of 1. We'll substitute 1 in for x in the f function. So the absolute value of 1 minus 2 is the absolute value of negative 1, which is 1. And that 1 will be fed into the f function again. So f of 1, we're going to repeat what we just did. The absolute value of 1 minus 2, which is the absolute value of negative 1, or 1. So f of 1 is 1. Finally, g of 0. Our rightmost function is g. We're going to substitute 0 in for x in the g function. So 3 over 0 squared plus 2, or 3/2. And then we'll feed 3/2 into the g function. So g of 3/2 equals 3 over 3/2 squared plus 2, or 3 over 9/4 plus 2, which is 3 over 17/4, or 12/17. So g of 0 is 12/17. Okay, so now we're going to look at function composition without values being substituted in for x. So these compositions will have x's still in them. They'll be functions of x. So again, I'm going to use red for my f function, blue for my g function, and first we're going to find f of g. So we're starting off with the g function, which is g of x is x squared plus 4, and we'll substitute in x squared plus 4 for x in the f function. So we'll find f of x squared plus 4. So I'm going to take my f function, which is x squared plus 1. Instead of putting x, I'm putting parentheses, substituting in the x squared plus 4, and we'll simplify. So that simplifies to x squared plus 5. So f of g, or f of g of x, is x squared plus 5. Okay, so f of g was x squared plus 5. Let's find g of f. So we're starting first with our f function. So f of x is x plus 1. And we will substitute x plus 1 in for x into the g function. So g of x plus 1. I'll write my g function, which is x squared plus 4, but instead of writing x, I'll put parentheses so I can substitute in the x plus 1. So now I'll simplify x squared plus x plus 1 quantity squared plus 4 and get x squared plus 2x plus 1 plus 4, or x squared plus 2x plus 5. So g of f is x squared plus 2x plus 5. Let's look at f of f. Starting with the f function, we've got f of x equals x plus 1. And we'll substitute x plus 1 in for x in the f function. So now we need to find f of x plus 1. I'm going to put parentheses plus 1 and substitute x plus 1 into parentheses. Simplify, we get x plus 2. So f of f is x plus 2. Finally, let's look at g of g. We're going to start with the g function. G of x is x squared plus 4. We're going to substitute x squared plus 4 into the g function. So g of x squared plus 4. I'm going to write parentheses squared plus 4 and fill x squared plus 4 into the parentheses. Now when I square x squared plus 4, we get x to the 4th plus 8x squared plus 16. And then we still have plus 4. Simplifying, we get x to the 4th plus 8x squared plus 20. So g of g is x to the 4th plus 8x squared plus 20. Okay, finally, let's look at f of x being 4 minus 3x and g of x equaling 1/3 times 4 minus x. I'm going to use red again for my f of x function, blue for my g of x function, and we're going to look at f of g of x. So this is the alternate form of writing composition. So here, when it's written in this notation, we'll do the inside function first. So I'm starting with g of x, which is 1/3 times 4 minus x. And I'm going to feed that in for x into the f function. So I'm going to write f of 1/3 times 4 minus x. My f function is 4 minus 3x, and instead of x, I'm putting parentheses so I can substitute in my 1/3 times 4 minus x, and now we'll simplify. So I'm going to do 3 times 1/3, which becomes a 1, so 4 minus x, or 4 minus 4 plus x, which is equal to x. So f of g of x is x. Let's look at it the other way, because it's not necessarily, function composition is not necessarily commutative. So let's find g of f of x. Here we're starting off with the inside function, which is f of x. F of x equals 4 minus 3x. We're going to substitute 4 minus 3x in for x in the g function. So g of 4 minus 3x, or 1/3 parentheses 4 minus parentheses, and I'll feed 4 minus 3x into the innermost parentheses. Now we need to simplify. Let's start on the inside. So 1/3 times 4 minus 4 plus 3x, or 1/3 times 3x, which is 3x. So here, f of g of x equals x, g of f of x equals x. And in the next section, we're going to find out that this means something special when that is true. And just as a sneak preview, these two functions are inverses of each other.